Hello there, welcome to this Shieldier guide where I will discuss the Damn Vulnerable Web App file inclusion vulnerability on low security from the red team perspective. Today we're going to be interacting with quite a few tools to be able to engage with this vulnerability. If you would like to follow along at home, as always, please follow the prerequisites to bring up the lab on your host system, either from the red or the blue team. This video, however, will just be covering the red team perspective. We're going to use a few, as I've said, a few different tools for both a remote file inclusion and a local file inclusion. We will go over some techniques to be able to identify if you have local file inclusion. We will also cover there are some undocumented bugs in some of the files, so we will do some fuzzfossyfull and Python to test for cross-site scripting. Why are we talking about cross-site scripting in a file inclusion video? We'll just wait and find out. We have here a sequence diagram of the attack. Again, just preamble in that section, but here we say, okay, we can get a specific file or try and get a specific file from the server. The server will then attempt to access the file system to see if that file is there due to a vulnerability within the application code. Then if it is successful, we can read the response from that file locally. If it's not successful, it'll give a warning or it'll just give nothing in most cases. First of all, we can go through with a basic browser just to have a look around to see what we're dealing with before we try and automate this testing. Again, just Firefox and then go to the Damn Vulnerable Web App. You're going to need to log in, admin and password. We can then set the security appropriately to low for these guides. Going to our file inclusion, we are presented with this page where we get three options. File1.php gives us some information about our user and our IP address that we're connecting from, this being the Kali instance. We are then presented with file 2, a nice quote, great. Finally, file 3 gives us a bit more information, so you can see a user agent and a referrer header. Just something to look at, potentially. There may also be some other files located on the system, so it's always good to enumerate as much as possible. We're going to do the classic local file inclusion attempt. Here we're telling the specific application, the PHP app on this page, to load a different file. We're going to use relative pathing, which is the ... If we were to look at a file on this Linux system, we're going to be presented with ls_alh. Here at the top, it's going to say ... is this current directory that I am in, and then ... is the directory above the one I am in. So this directory will be the /home/ directory. If I were to move one directory back, we can prove that. Print working directory, I'm in home vagrant, and then if I go cd the ... and then print working directory, it's going to say I'm in the home directory. That makes sense how we can traverse the path with these double dots. So it's ... quite a lot of times, and then we wanted to read from the root of the file system, which is the /etc, where there's a lot of configuration information, the password file. This file contains information about the users on the system, and in an old version of Linux it used to contain their passwords as well. However, if there is an X, it indicates that their password is in fact in the shadow file, which is another, I believe, core utils, or one of them serve the shadow, so that you can have your passwords stored locally on the system in a secure manner, not just your passwords. So you can see here we are successfully able to get the file. We can see root and then X stored in shadow file, 00 for UID and GID. Then we can see the shell that user has is bin/bash. Now to confirm that, I'm going to read the password file on the Kali instance. So cat etc password, because it's also a Linux machine. This wouldn't work if you're hosting the Damn Vulnerable Web App on a Windows host, then it'd be or on a Windows guest, then there'll be some different constraints. However, here you can see root, and then all the way down you can see Vagrant, which is the current user that is used to spin up these Vagrant managed guests. But here root would be of interest, and then the contents of the file is the same, it's just presented in a bit of a different way in the browser. So we can say, yes, we have successfully executed local file inclusion. Why can we read this file? So a bit of a side channel, the Linux file permissions, it is quite I wouldn't say it's imperative, but it's quite important to understand why these files can be read by just a random user on the system, in this case the DVWA user. Hence, it is key to understand file permissions within Linux. If you'd like to skip the section, you're more than welcome. However, just to demonstrate, we can look at the file permissions of the etc password file on the Kali guest. It'll be the same on the Ubuntu Dan Von Web App guest. You can see that there are a few what they refer to as octets, and then the first bit, the sort of like sticky bit. In the post, it is explaining those things here. I will briefly go through them. We'll do it live. This indicates whether it's a special file. So if it should get the set user ID of another user when the file is executed. And then it'll also give information as to whether or not that file is a directory. Go ls-alh. In my current directory, you can see D indicates that it's in fact a directory and not a file. Clear that, run that again. Then we have three groups of three. Here is the user permissions, the first group. The second group is the group permissions, and the final group is the world permissions. So this file is readable by root, writable by root, and not executable by the root user. In the ideal, but it is, but anyway, we're not going to worry about that. Then it's the group settings are, it is readable by the root group, but it is not writable or executable. And it's similarly, the final permission set here is the world. Anyone on the machine can read this file. So no, it doesn't matter which UID that they have, they can read that file as long as they have access to that system. And then again, this is the user who owns the file, and then the group that that file is associated with, being the root group. Moving back to the post, chmod is how you'd interact with this the most. You'll see online people just go, oh, change the files to quad 7. So these are a binary representation of the file permissions. So a 7 in this instance is in binary 3 ones. So it is 1 plus 2 plus 4 would be 7, and then that gives the file read, write, and execute permissions for the user. Then for the group, it has a similar permission, 7 being read, write, and execute. And then for the world, anyone on the server can read, write, and execute that file. A more common file permission would be 644, which is what the etc password file has. So 6 being the first, well, the significant bit is set to 0, then the bit in the 2's place is set to 1, and then the bit in the 4's place is set to 1. So 2 plus 4 would be 6. So then it will also get the other bit, the 1 bit in the 4's place for binary set to 1, so therefore it would be 4, and then read only. So that's how you get read, write for the user, and then write for everyone else. And then you can set it to have no permissions if you really wanted to. However, I like to look at root as more of an operating mode than as a user, because it doesn't really apply in the sense that you would think it would apply these permissions to the root user due to how Linux has been set up. So now you can understand why the DVWA user is able to actually read this etc password file, because it is world readable. Obviously, you'd also need the exploits to exist within that file to be able to retrieve it. Like in this instance, there is an exploit within how it is handling what what page to fetch, you can pass it any arbitrary file on the file system, and it will fetch that file either by relative or absolute paths, which is another interesting little tidbit. Now, for the remote file inclusion, there's two methods we can test this. We can get a full reverse shell on the machine, but first I would like to demonstrate just serving a simple text file from our Kali instance and then having that retrieved from the server that we are targeting, which is a bit of an easier way that we can verify instead of going through all of the setup that we have remote file inclusion. First, we're going to want to bless the Python application with the ability to bind to privileged ports, which is this command. And then when we do the reverse shell, we're going to have to do the same for netcat. I have already done that, so I'm just going to serve on port 80 a particular directory. I'm going to cd into the temp directory. I'm going to then echo hi there into a file called hi.txt. Now I can cat that file, and then we can confirm that it has hi there in it. Now that file will be served when I run the Python server. We can then, like it is explained in the blog post, read that file remotely from the damn vulnerable web app. So we're saying here, we're giving it a network, so protocol, and then saying that's where it is on the network, on port 80, and then here it's the rev shell, but I'm going to change that to be hi.txt just to confirm that we do in fact have the remote file inclusion. So hi.txt, and you can see here, hi there. So that is successfully confirmed that we do have remote file inclusion. We can then up the ante and do a full reverse shell if we want to, which we do. That's the goal, that's the aim. Again, have the reverse shell from rev shells. I will show you how you can generate this. So you want the IP address 192.168.56.200 would be the IP address that you want the rev shell to connect back to. And then on port 443, don't worry about root permissions required. We've already set that with the capabilities for that particular application. So then we want PHP pentest monkey. We want to copy this, then paste that in. I'm going to remain in the temp directory. We're going to paste it in a file called revshell.php. So vi revshell.php. I'm going to press I in normal mode to go into insert mode, Control-Shift-V, which will paste the contents of the clipboard in insert mode into Vim. Then I'm going to hit escape. Normally it would be there, but for me it's just a bit easier to put it there. I'm then going to write and quit. So you could do write quit. However, I just do X, and then that will write quit the contents of that file to disk. Now we can do a little head N10 for the rev shell, and then that gives us, yes, it has successfully written to the disk. With that being said, you would now run the Python web server. That is already running, so we don't need to worry about that. I'm going to, however, cancel, clear the screen, and then rerun it so that it's a bit clearer as to what's happening. We put that on this side of the screen. Then we're going to do the netcat listener. So we've got two things listening on our remote server. One for the rev shell. It doesn't have to be hosted on this particular server. It could be hosted anywhere on the internet, as long as the targeted server, the targeted server being damn vulnerable web app, can reach that location and then correctly understand the contents of that file. For now, it's just going to be hosted on the Kali instance because that's easy enough in this engagement. Then we're going to open up the reverse shell, which is where the connection is going to be sent back to. So first is the Python instance that serves our reverse shell to the damn vulnerable web app. The damn vulnerable web app will then download that, read it, execute it, and then connect back to our reverse shell, which we'll use netcat to listen in on. So we're going to do another terminal window. You can set the capabilities of netcat with that particular command. However, I don't have to because I've already set it. So it's going to be netcat nvlp for port 443. Then that's going to listen for any incoming connections on port 443 on the Kali instance. Now, finally, we are ready to execute the attack, making this request with a logged in session in a browser to the down vulnerable web app. So here we can say page equals our remote machine, then the IP address, the specific port we want to target. It's a bit redundant to put HTTP and then the port 80, but I'm just being particular here. Then the specific file we want to retrieve, which is /revshell, because our Python server serves relative to wherever you ran the Python server from, so you don't have to say an absolute path. Instead, we can just say a relative path. Now it'll look like it's hanging. Oh no, it's broken. What's going on? It's not actually broken. It's just actually executing the reverse shell. Here we can see that connection from 5671, which is the damn vulnerable web app, get revshell.php, and then the server responds with a 200. Yes, the file is there. Here it is. Now in the netcat listener, we can say, we've got our reverse shell. There we go. So that is one method you can utilize if you have local file inclusion. Also test if you have remote file inclusion. So I mean, in the rev shell, you can do basically anything you want. You want to escalate your privileges and all that, which won't be covered in this guide. But that's that. Moving on to another method that you could exploit this, just using curl. So how we would normally populate the PHP session ID, then you can do a curl with the correct cookie set and the page that you want to retrieve. That will also then in the browser respond with the contents of the password file. You can see here this image, though it hasn't quite worked because I'm using a different way to screenshot these things, but it should respond with the correct information. We'll fix that before posting. Now, fuzzfosteryoufull is another method you could use to enumerate which directories you do actually have access to if you suspect local file inclusion for that specific PHP application that's running on the web server. You'll need seclists installed, so sudo apt install seclists will get you what you need. Then we're going to populate the PHP session ID with a valid session. I'm going to move myself to this side of the screen if I can. There we go. So this PHP session ID curl subshell explained in the command injection as to why that works and why if I do an echo for PHP session ID, there will be a value in it now, which looks like a PHP cookie. Next, we're going to use fuzzfosteryoufull and then the attack. So fuzzfosteryoufull, the URL that we're targeting, and then the fuzz keyword, so that's what the word list will inject all the values into. Match condition being 200, we want to filter the response if it contains the word warning, because those don't work. Then you want to set the cookies to security low and the PHP session ID to what we've set there, so it can access the password protected parts of the damn vulnerable web app. Then you want to specify the word list. Again, this is seclists, must be installed. That will then go through and test to see what files we do in fact have access to. So a lot of etc password files with the relative paths. However, here's something interesting. With an absolute path, we have access to resolve.conf. Looking in the browser, we can try and access that file with its absolute path. And in this, that looks like an actual file. That doesn't look like, it's just a commented out conf file. So we do actually have access to it with the absolute path, not just the relative paths. Then you can go through and pick and choose what you want to read from the server. Now, as I alluded to in the beginning, there is another exploit here that's one of the undocumented, I'll put it. File3.php has an interesting thing that it shows you. It is showing you your user agent. Who controls our user agent? Yes, that is right, us. So we can change that to anything we want. You're going to need a few prerequisites to be able to get this to work correctly. You're going to need Burp Suite, which is pre-installed. However, you're going to want a way to proxy your browser connections through Burp Suite's proxy so that it can manipulate the requests and if you wanted to, the responses that you get back, but primarily just the requests to the server. You want that to be manipulated so that we can alter parts of our request. You can see here, for instance, if I move myself, you will see within the network section, in the headers, you'll see our user agent as being that value there. Those are the same, that's the same value. So we want to alter that to be something else so that we can then print it to the screen. But now you'd want to install Foxy Proxy for Firefox in this instance. So Foxy Proxy Firefox add-on. I don't know, like if they call it add-on or extension or whatever, but I think it's an add-on. Foxy Proxy downloads, GitHub. We want to look on, there we go. Add-ons, Mozilla, Foxy Proxy, add to Firefox. And don't worry about that. We're just in the, doesn't really matter too much. We can now see, no, not the deprecated pocket. We want to look at open extension, options. Okay, that's fine. We don't need to worry about that. We want to add a proxy, hostname 1.1, and then title to be burp. Save. Get those two correct, and then you should see a burp proxy session here that you can open. We don't want to open it yet. First, we want to fire up Burp Suite, the community version. Don't worry about the JRE, the Java runtime environments. We don't need to worry about that. It will then take a little bit to start up because there we go. I accept. Temporary projects is the only one that we can do in the community edition, which is fine. And then using defaults, which is fine as well. Now that that has finished loading, we can set the proxy. We want to do intercept on, which will intercept all of our web requests. You can also set the root CA so that it can do certificate authority interception and decrypt encrypted content. Instead, we want to refresh this. We want to turn our proxy on. So select burp, and now we will be proxying through Burp Suite. When I do that, it should say, okay, we've got a GET request here. We want to add that to scope. So in the target, we have that as our scope, which just reduces some noise. We can now forward this request, and then it'll be rendered within the browser. So we want to do file inclusion, forward. There we go. Now file 3 is what we want. It will then do a get for that specific file, and here we're going to edit our user agent to be something else. I'm going to say, hi, I'm on TV. We can forward this request then, and it has successfully changed the user agent, and then it's displaying that here. We can then set it to be something a bit more interesting. We want, that's just what I've explained. We want it to be this, user agent to equal that, a cross-site scripting attempt to see if the page will actually render these scripts. We want to then refresh the page so that we do the request again, altering the user agent to be that, and then forwarding the request. There we go. Cross-site scripting. On any difficulty this works on, because this is apart from the normal controls. Boom. Look, I'm on TV. Awesome. So we have successfully cross-site scripted this part of the application. Then there is another parameter that can be edited. Just quickly looking here, what other parameters do you think you can edit? And then if you fill that with something, does it do anything? Something to think about. I'm going to disable the proxy now and close Burp Suite because we're finished with it for now. Do I want to exit? Yes. Moving on to something a bit more advanced, we can use fuzzfastUFull and Python to be able to, because there's no way that I'm aware of within the terminal to render JavaScript, because that's where this exploit is taking place. It's within the JavaScript frameworks of the browser. We can instead use fuzzfastUFull and Python to be able to script this and automatically test for these vulnerabilities or these exploits. Here it is explaining you will need Chrome driver installed for the Python Selenium package to work properly. If you also try a Python 3M install Selenium, it will go, oh no, externally managed environment, blah, blah, blah. There is, from the amazing Jeff Geerling, a post on how to remove that lock from your Python system. Then you're going to want the Chrome driver installed. So we want Chromium and get the version. So I'm going to do it in a bit of a different order than it's explained there. I'm going to clear that, minimize that, and then we're going to get the version. The build version we want is that. We can then download the specific Chrome driver for that version. So wget for that. I'm going to copy and then doing a replace for your version. There would probably be a subshell way to do this, and then it'll be nice and automatic. However, I wasn't in the mood to, but you can. There we go. We've got the Chrome driver. Now we want to install it. First of all, we are moving it to where it should. Well, we're going to want to unzip it first. And I'm not going to be in the downloads folder, so this relative path won't work. Instead, I'm going to move the package to the downloads folder. So move Chrome.zip to downloads, cd downloads. Then unzip Chrome driver. You can see there it's inflated as a directory. We're going to then move the Chrome driver specific driver to where it should be on the system, which is user local share Chrome driver. Again, if you already have one installed, you're going to need to remove it. We're going to then make it installable with these two commands. Well, this one command that's double ampersand linked. And then I'm going to want sudo. So the way you can move around is Control A to go to the beginning of the terminal command, and then Control E to go to the end. You can just move around quickly like that if there's something that you needed to fix in the beginning of the command or something that you need to fix at the end of the command. It's nice and easy. We're going to run this. You need to begin double ampersand sudo. They both get tokens, etc., etc. We're going to link that to user local share bin Chrome driver, and then also linking it to the user bin Chrome driver. Now, where is Chrome driver? Sweet. So it's successfully installed. We're going to now make a directory, the fuzzfastUFull out directory, for all of the outputs to happen. I'm going to go to temp because I don't want it to fill up my downloads. Not that it's that much, but again, we just make it. We've already made it so it's not going to recreate it, but make dir for that directory. We're going to then populate our session cookie. Again, it may have expired. So it's always just good practice to populate it again with an up-to-date session cookie. Now we're going to run the fuzz42full scan. What this is doing, it will look familiar. We are providing it with the URL that we want to target. Then we are providing with a header. This is a bit of a new piece. We are changing the user agent header value to be fuzz. So that is what we are going to fuzz in this instance, is the user agent, as opposed to fuzzing a page, because here we're providing the exact location that we want to fuzz, then the exact location that we want to target, then what we want to fuzz is the user agent. We're going to do a match condition on 200. We want everything. We're not going to do any other filtering, because the filtering that we have to do happens elsewhere. We then set the cookies, security low, PHP session low. This could be security, could be anything, because this vulnerability exists no matter what security level you're on. Then the word list. And the specific word list that we're going to use again is from seclists, one of the cross-site scripting word lists. Then we're going to output that to a directory. So all of the, instead of it all happening in memory, all of the requests that are made, the responses, we're going to output to the directory that we've just made, fuzz42full out. That's then going to go through all 114 attempts and both output it to the screen. And now if I look at there, these are MD5 hashes for all of the requests that we've made. To then do this script is a bit more, it's a bit less optimized in the later script that I'll explain in another post. But this script, all it does is goes through and formats these to be able to be run through the Chrome driver, so that we can then test to see if the cross-site scripting actually worked. Because we can, for instance, I'll CP the 01, let's say take this one, and then I want it to come into this current directory, and then I want it to be named the current file name plus HTML. So that would be $_ .html. Would that work? No. Oh. But anyway, we'd want it to be, I mean, that only works if it's multi-commanded. We're not going to worry about that though. So I want it to be just asdf.html. Now we can use Chromium to read that file, ASDF. So now it's going to display it. Go, okay, cool. There's issues with this though. It's not great. I mean, yeah, it's broken. It's broken. So instead we want to fix them. One of the ways to fix them is documented here. You can also vi it. You can exit vim, was what we just done. We're going to move full file in the directory. We're going to then rename them to end.html, because Chrome by default won't render it as a page if it doesn't end in .html. It's a bit of a pain. So now all of them end in .html. We're going to then comment out part of the header field so that it doesn't look like the mess that I just showed you. Now if I CP one of them, that's not going to work because it's .html to asdf.html. Hopefully it doesn't have the no clobber nonsense. Now we're going to want to Chromium ASDF. Now it's actually rendered as a page. So it looks like a proper web page now. Going to clear that. Then we're going to run the Python script. Finally. This is just a little, partly generated by ChatGPT, a little Python script that I put together to go through all of those files in that directory and then see if there is a message body, if there's an alert message, and if that alert message successfully contains a value. So we're going to paste that into, here it's ssscheck.py. So I'm going to vi nvim, oh no, I don't have it, so just vim xsscheck.py. Doesn't really matter what the name. Again, insert mode, paste, exit. Now that is successfully written to the disk. We can then run it with that. There are some hard-coded values. For instance, the directory that it's going to be using to read from is referenced relatively from the current directory, and then it'll be there. In the newer version, it's all fixed and it's nice, and don't worry about it. But this is just to give you by way of example. We can then, I need the Selenium driver, which I skipped over here. So we want to run that to install Selenium. I'm going to do this in a new window and then see if, cool. It's already, yeah, it's not going to give me the warning for that. Awesome. Try that again. Bugs. I'll be back. Okay, we're going to rerun the Python script. They have changed. It's no longer Chrome driver. It's just Chrome drive in some of the files. We're not going to worry about that. Instead, the guide will be updated to better reflect that it's no longer downloads Chrome driver. It's instead just Chrome drive. That's what I must have done. I didn't copy the full path. I only copied up to there. So just be careful when copying and pasting these things. But it's fixed, updated now, so it works. We're going to run the Python 3 cross-site scripting check.py. Then it is going to, using one of the parallelization tools where it can run multiple, you can see the CPU's really beefing up. It's not going to run it in sequence because we don't need that. We can make use of some of the parallelism and run it on multi-threading. You can see here in the script with concurrent features, thread pool exec as executor. That then creates multiple instances of this. We're then doing the check here. We're going to do a sleep 2 just to make sure it correctly alerts. And then if it does alert, great. If it doesn't, don't worry about it. So yeah, it's almost done. So those files have successfully alerted. We can then read one of those files. So we're going to take this one again, Control-C. We're going to head, actually we're going to just chromium that specific file. Now that it's successfully run, we can then start testing these files. The first file doesn't work, but this file does successfully produce an alert 1. We can then test that file by doing a chromium and then for that specific hash. It should then say, boom, alert 1, great. Now, what was the input that allowed this to happen? We can do a head n10 for that specific file. That will then give us user agent, audio source, onboard source alert 1, and then that user agent would successfully cross-site script. So you can go through each of those and then check to make sure that they do in fact work. So, and you can see that this is just commented out. So it doesn't include this, which is what we did with the sed command. It doesn't include that in the actual displaying of the web page because we don't want that, but it does work. And yeah, that's how you can use Python to augment some of the cross-site scripting that you're doing. And that is all for the red team perspective. Thank you for joining me for this one, and I'll see you next time.